Hello and welcome. So I would like to do today is a follow-up to the previous recording on the Crystal SQLite adapter that we did last time, and the introduction to the Pragma changes and how that impacts on the developer experience, how that is usage, and of course do some silly benchmarks, right, that we're here. Um, it's on my site. The idea was to the Pragma parameters to be able to use the connection string when you're opening a database connection, and then be able to avoid having to do the setup connection to execute each one of the pragmas manually and get that done automatically by the adapter. And that actually, I created a pull request at that moment that presented that, and there's been a back and forth with the maintainers just to make it that more efficient. Honestly, because what I presented at the moment was using a hash, and they make a recommendation using a macro that perform much better, and things looks good. So what I would like to do is just do some testing with that. So I set it up here a project where I have a shard. This project has some dependencies, of course, depending on the DB, Crystal DB, and the SQLite adapter for the database. I'm going to do an HTTP server that we can get here on the code. The HTTP server is really something simple, just to give some randomness to this. It's going to fetch a contact from a database, select the name of it, and then return that in the response as text plain. Okay, and this is a simple HTTP handler application. You can see here that I'm opening the database, and then I'm setting up the connection to it, and within that I'm passing all the pragmas elements that I need to do, right? So all this like journal mode, so write ahead log, making sure that making the synchronization into a normal mode so it performs much better, increase the cache size, and adjust the busy timeout so writes are not blocking replication process and things like that. So and then like working like on HTTP server, like building in the middleware, building a chain of the app and the logger, trapping on exits, listening on the IP address, listening, and then at the end, as following the indications of the documentation, making sure that I close the database connection, right? And I set it up a script to generate that database. So it creates the table context, it inserts context in it. Those are the two SQL queries, and then like I just do random things. It just populates 500 contacts, and that's it, right? What I'm be using differently on this is I'm just continue using the hydrofoil crystal container image that I use pretty much for everything, because I don't have crystal installed. And what I'm going to do is just do compose up. This is going to boot up the application, install all dependencies, build the server, and then launch the server. That sounds a lot, but that's what I'm using watch exec to do that, and it's invoking shard run command that's going to run the server target, and by doing that automatically install the dependencies if it were missing. That's a shard property, and then it runs the server, so it's going to compile and run it. And the good thing about that is like now you can see the server is running here. You see server listening on that port, and I can press Ctrl C to stop, right? If I did an update to the server script and I press it Ctrl S, so that automatically triggers a rebuild of the server, and it rebuilds it and it executes the server. So it's kind of like a shotgun for those that were familiar with Ruby, that actually terminates the process and automatically executes the new version when it detects changes. So that's basically it. So I'm going to test that server. I'm going to just do this, localhost 8080, and oh, sorry, it should be oh, I'm getting an internal server error. Oh, we don't have the table context. So if we take a look, we do have the database, and since we're using write ahead log, it already created all the additional files that it needs, but the context database that I have here, it's empty. It doesn't have the table that is necessary. What I'm going to do is I'm going to enter in the same container that exists, but using a shell, right? And I'm going to do shards run generate. So this is going to compile the generate script, and it's going to execute the generate script. And now it should have some context. So if we exit this and execute curl again, now we get hello name 243, right? So now the request, as we see here on the logger, is logging that correctly. Now, the idea with the pull request was to get rid of this. So what I would like to do is switch to that. So if I was in this ideal, in this mode, I will be doing something like this. Wall, journal, and then I will do synchronous. Synchronous will be normal, and cache size will be 60 megabytes. Yes, it's a negative value, and you can read on the documentation from SQLite. It seems to be like a support regression kind of thing. Now, if I remove this and save, this is not going to work because I'm right now using the target, the official target, right? So what I'm going to do instead, I'm going to stop this, stop the container. I'm going to adjust these dependencies to point to my fork and to adjust to my branch. So what I'm going to do, I'm just going to copy here from the pull request, copy this, and I'm going to say here is going to be on GitHub, and it's going to be Luis Lavena Crystal SQLite3, and here is going to be the branch. Okay, I'm just going to remove that, save it. I can comment this out actually, or remove it. I don't need it since I have those in the query parameter and the URI parameters now. Save it. Since I stopped the server, nothing is going to happen. What I'm going to do, I'm going to do a compose run, and I'm going to do a shards install. So I pick up the new dependency, and I can see that install it with a different commit than it was before, and that commit is the one that is latest on this branch, which is this one. Okay, so confirm that it's working, and then I'm just going to do compose up as before. Dependencies were satisfied, is built in the server again. Okay, if I do the curl, it continues to work. And just to fully confirm that, I'm going to delete all the DB files. Okay, so if I list, there's no DB files. If I run things again, this should automatically create, it's going to build the server, run it, but this should automatically create the wall file, and it seems it didn't. Huh. Oh, I know ways. I'm going to remove the lib directory, and I'm going to install again, fetching, installing, building. Okay, and if I run it again, now is it. It seems that even that I did shard install, because it was in the lib directory, it detected that was there. It didn't pull the new version, even that it says that it pulled the new version. I don't know why. Maybe that's a bug that I need to report to the shards project. Anyway, so that's running, but of course it doesn't have the dependencies running. So what I can do actually, instead of doing that, I will do just shard run generate, just to build the generate, so I can populate the database so it has context, right? So the database is there, but you will see that the wall before the write ahead log was empty, and now it's waiting 2 megabytes. And that's because every transaction gets added to the wall file and not to the original file. So you can read a little bit more about how the SQLite write-ahead log works, and it's quite interesting. But that allows you to have multiple readers simultaneously and potentially like just queue up the write. So it's actually provides you a really good performance. But here we are in normal mode. What I'm going to do, I'm just going to try to do a plow with, I don't know, 2 concurrencies for 10 seconds to that server just to see how it works, right? And of course that's giving me like 5,000 requests per second. If I go here, I see all the requests, right? And something interesting, the build is not in release mode, and the logger itself also slow things down. So what I'm going to do instead, I'm going to stop this. I'm going to do a compose run on the app, and I'm going to do shards build release. So I'm going to do the build of the server script, release mode, and static. That's a lot. But this is going to do, it's going to run that inside the container, so it's using an Alpine Linux. It's going to build in release mode, and it's going to build a static executable, so it will have no dependencies, right? So, oh, I forgot to remove the logger, so let's finish building. I should, well, that's working. I should come here and remove the logger, but we should benchmark this just for performance sake. Okay, so that's building. Since it's building in static mode and in release mode, it takes a little bit longer to do it. A couple of more seconds. While we wait, the good thing is like now all the setup connection elements are gone, and now I have this in a simple URL fashion, in a simple URL, and I can even have this set up in an environment variable if I want it, so I can control the pragmas that I need. Say for example I wanted to control the size of the cache, or I wanted to control the journal mode or the busy mode. There's a couple of other pragmas that were added just to have a better control of the checkpoints for write-ahead log. So it will be good to take a look to that. Now I see it's 19 megabytes executables. If I do in server, I have the server here. Oh, sorry, I'm on a Ubuntu, or actually a Pop OS Ubuntu derivated distribution, but I can execute that executable because that's been statically linked. So I can do bin server. I have the server running, and if I come here and I run the benchmark it again from 5,000 requests per second now to 14,000 requests per second, not bad, I will say. And that's just doing some random things, but it has a logger, right? So I'm just going to move that, the server, and I'm just going to do server logger, I don't know, and then I'm just going to do the rebuild again. And of course, since I'm using release and static mode, that will take a little bit longer, so bear with me while we wait for that to happen, right? Here, while we wait for that, I'm inviting you to go and check it out, the hydrofoil crystal. So if you're running containers for development, or you're running containers for everything like I'm doing it, this runs allows you to test different things. And in this particular case, I'm using Overmind to run the processes. On the proc file dev, I have only the server definition, but you can use it for auto specs, in a sense of like it detects changes on your spec directory or on your source directory and automatically rebuilds. In this particular case, I'm only using for the server, but you could go and define other type of processes that do other type of things. You can find that in the hydrofoil crystal repository, and you will find here on the examples way of using this and what it means, every single line that you see there. Okay, well, it finished building the server. So if we take a look now to the server again and we run it, so before was 5,000 requests, the new one was 14,000 requests, and if we run it again, and this is only with concurrency, the same duration. Of course, this is synthetic benchmark. This is just local. We're not hitting on the network. There is no over the latency about like establishing SSL connections and those kind of things. So just ignore that. This is just for the sake of testing. And the server was running. And what I'm going to just to do here, I'm just going to start here. I'm going to filter by server. Oh, maybe I just filter by bin server. That will be easier, right? And I'm going to come here and increase number of concurrent connections just to 5, just to see if there's like changes. Before was 38 something, and here we see CPU usage is good. There isn't a lot of memory usage that we can tell from this, which is really good. So 64, 65 megabytes of RAM virtually allocated, but not necessarily on the process itself, right? And it did 39,000 requests per second, so not bad, not bad. And of course, this is like a really simple script that only randomly picks one from 500 to show a name on the response. So it's really silly, and it's all mostly because of some of the parameters are being tweaked here. It allows to work more efficiently, and even allows to have concurrent writes. So, well, not concurrent writes, but like it will have a write and you can have readers at the same time. So in this particular case, I only running this in single thread mode. So this is the default mode for Crystal at this time. This is a single thread mode. But if I wanted, I could come here and say do a preview, multi-thread, do a release static with that, and I don't know, let's see how that goes. This of course is going to enable the multi-thread mode. I hope it doesn't explode. But with this enabled, in theory you should be able to control how many processes or workers are going to be able to pick up the queue and be able to process things multiple times. And since the DB adapter or the DB adapter is already multi-thread capable, it should work by automatically managing multiple threads on the same process. So let's see, by doing this, and I think that's on the Crystal documentation. Crystal, let's go to learn, and that should be on concurrency, if not mistaken. No, that's concurrency, but it's not threading. I don't remember exactly. Anyway, what I know is that you can use Crystal Worker and set the number of workers. So I have 8 processors, actually 4 cores and 8 threads. What I'm going to do is Crystal Worker, I'm going to set at 6. I'm going to do bin server, and I hope that doesn't crash. So we see here it spawned in multiple threads, so it has spawned multiple processes and threads. I don't know which one is. And if I run this, oh, okay, it just crashed it. Okay, so I think there's more work to do for the multi-thread on SQLite. Anyway, that's all for today. I just wanted to try something up and maybe potentially report some issues with the shard comment and things like that. I hope you like it, and see you soon.